In this video, we are going to start looking at the digital outputs of the Arduino, and we're going to do that by driving some really common circuits. The first one is going to be an LED, and the second one is going to be a servo motor. So on the Arduino, it brings out 14 general purpose digital I/O, and the word digital means that the output is either going to be one of two levels, and we call it just a logic high or a logic low, and these essentially correspond to a low being the lowest voltage in the system, which is usually ground, and a high being whatever the highest voltage is for this particular logic level, and in this case it's either going to be 3.3 volts or 5 volts. But when you program it, you don't actually care about what the voltage levels are. You just know that if you tell the output to be a high, it's going to be a high voltage, it's 3.4 volts, and if you tell it to be low, it's going to be 0 volts. Okay. Now the Arduino itself, of course, brings out these I/O to pins, and usually the way that you access them is you plug in what we call a shield. And we are going to be using the Board of Education shield from Parallax, and this board is going to allow us to have a little prototyping area so that we can easily connect up LED circuits, and it's going to allow us to connect to servo motors, and it actually has connectors to drive servo motors and the necessary power in order to do that. Okay, so the first activity that we need to do, though, is we need to set up the Board of Education shield with the Arduino. So what you're going to need at this point is your Board of Education kit. Okay, so this kit right here is from a company called Parallax, and we're going to be referencing their tutorials also. And this box comes with everything that you need to basically assemble a robotics platform based on the Arduino, and it also comes with an Arduino. And you're also going to need some batteries. Okay, so you're going to need to get 5 double A batteries, and when you open the box into this, one of the first things you're going to see is you'll see your Arduino, of course, the Arduino Uno, which is what we're going to be using. You'll have a programming cable, and you'll also have the Board of Education shield. And so this is what we're going to be doing here. Okay, so now you are going to go ahead and do this assembly, but let's take a look at this first. So let's take a look at the Board of Education shield. What's neat about it is that all the digital I/O from the Arduino come up through the same connector style right here and here, and the reason they do that is because you can actually plug another shield on top of the Board of Education shield, so you can make kind of a big stack. The digital I/O are also routed over here along this little header right here, and you can use those to use jumper wires to get into what we call the prototyping area, or this little breadboard. It also routes over 3.3 and 5 volts and VN, which would come from the batteries, ground down here, and then it also has some analog ins, which we won't cover now. It's also got a power switch, which is really neat because you can, if you don't want to use the Board of Education shield, the BOE Shield, you just leave it in position 0 and power doesn't go to it, but the Arduino can still be powered through the USB cable. If you put it in 1, it'll only power this area, the prototyping area, and then if you put it on 2, it'll power the prototyping area and also provide power to the shields. Okay, so when you do this assembly, what we're going to do is you are essentially going to connect the Arduino to the Board of Education shield, and all you're really doing here is you're basically just going to take the Arduino and you're just going to be plugging it in like this so that it hangs out like that. And one of the important things here is that you align these pins correctly, because if you don't do these pins correctly, then you'll have all sorts of problems. Now, the details of this, you're going to need to pull up your tutorial from Parallax. Okay, so this Parallax tutorial is going to walk you through exactly what you're going to need, and it's going to have you have some standoffs and some screws, and you're actually going to not only electrically connect these together, but you're going to mechanically connect them together. And so it gives you some guidance in terms of where the pins are going to go, because the pin header on the Arduino is actually larger than the number of pins on the Board of Education shield, or the BOE. So when you come down here, when you plug it in, you'll notice that the Arduino is going to have some connectors that don't have pins in it. Okay, so you just got to make sure that you line that up. So like this would be an example of doing it wrong. Okay, so you're going to go ahead and do this activity. One little piece of guidance that I will give you is they call out some of the screw lengths. So they'll, when they tell you to do this thing, like for example, they'll say you need a 7/8 440 panhead screw. That 7/8 is 7/8 of an inch, and it refers to the total distance of the screw itself, so including the head all the way down to the tip. And for the small ones, like a 1/4 inch, you're gonna have some 1/4 inch and then like some 3/8 of an inch screws throughout this assembly later down the road. It's handy to just take a ruler and put the screw right next to it to make sure that you actually have the screws. Okay, one of the things that I will caution you on is I was not able to get this plastic standoff in this hole right here. So when you go to do the assembly, the connector right here blocked it. So I didn't assemble that one. I just went ahead and did these two right there. Okay, so at this point, go ahead and pause the video and do the assembly, walk through the tutorial with the parallax, and what you're going to end up with is just these two connected together. Okay, so now we are going to start looking at how you actually drive the digital I/O with your Arduino, and we're going to start by driving a very common circuit, which is an LED indicator light. So an LED is a light emitting diode, and you probably see these in all your electronics. The BOE kit comes with these red LEDs, and what we're going to do is we're going to put this circuit right here off of pin 13 and off of pin 12 of the Arduino digital I/O. And what we want to do is put a 220 ohm resistor and a red LED in series to ground. So a couple things to bear in mind here. The resistors that you get in this kit are color coded, and we want a 220 ohm one. So there's the way that you look these up is you use the resistor code color codes. And for a 220, it's going to have a code of red, red, brown, and that stands for 2, 2 followed by 1, 0. So in your kit, go ahead and grab two of these red, red, browns. And then you're going to connect that in series with an LED. Now the way that an LED works is it's actually polarized, so it's got a plus and a minus. The plus lead, which is, they call it the anode, is indicated by a longer pin, and then the cathode, which is the shorter one, is indicated by a shorter pin. So what you can do is you can actually use the prototyping area of the BOE Shield to do this connection. So here's an example. The digital I/O are brought out to this this connector from the Arduino, and they're labeled over here digital, the pin number 13 and 12. And what they did is they just stuck the resistor directly in the connector and came over into this prototyping area. And remember that on the breadboard, these 5 are connected. So if you put the resistor lead into that hole and then you put the LED hole or lead into that hole, they're connected. And then what they did is they wired it down to here and then put it down here and picked up ground there. So what I did is you can actually stretch these over and you do it without wiring. So you just got to keep in mind that the longer lead of the LED connects to the resistor. So there you have it. That's how you're going to wire this up. And what we're going to do now is we want to write a program to turn these on and off. So the way that you do it is there's two instructions or two functions that we're going to use, and the first one is going to be called pin mode, and it's how you set up an Arduino digital output to be either an input, or excuse me, an I/O pin to be either an input, an output, or an input that has a pull up resistor on it. So don't worry about that right now, we're going to do it as an output. And then all you do is you use a function called digital write, and you just tell it what pin you're going to write to, and then you give it a high or a low. Now in a digital signal, high means it's going to typically be a high voltage, the highest voltage that the Arduino uses, which in this case is usually a 5 volt. It can also be a 3.3 volt on some systems. And a low is going to be the lowest voltage, which is going to be 0 volts or ground. And what's neat about it is that it's either going to be one of these two values. And within the program, we use high or low, and we don't really even care about whether it's at what voltage level it's at. We just want high to turn on the resistor LED circuit and a low to turn off the LED resistor circuit. Okay, so let's go ahead and do this. So what I'm going to do is I'm going to fire up a new Arduino sketch, and the first thing I'm going to do is I'm going to go ahead and save it. And if you're looking at the the parallax tutorial, you'll notice there's actually chapters in it. So let me go to the desktop here. And so what I want to do is I'm going to start naming these sketches a little bit more descriptive, since they have, for each chapter, there's like an activity 1, 2, 3, and so we can't call them activity 1, 2, 3 anymore, or else it doesn't make sense. So I'm actually going to call this chapter 2, and then activity, this is activity 2, and we'll just call it LED blinking. Okay? And let's go ahead and do this. So the first thing that I'm going to do is I'm going to come into my setup, and whenever I access the I/O, I always like to have the serial monitor going, because I'm going to be able to print stuff to the screen in order to kind of tell me what's happening with what's going on my system. Okay, so I'm going to go ahead and set up the serial monitor here by doing serial and then our traditional begin, and this is just a nice way to kind of debug things. So let's go ahead and go serial.begin and set it up to be 9600, and then I'm going to go ahead and do serial.print, and I'm going to do this activity 2 LED blinking, and I always do that so that I know that it's running the program that I think it is. And now what I'm going to do is I'm going to use this new function called pin mode, and all I do on this is I give it the actual pin number that I'm going to mess with, that I'm going to configure. So I'll do 13, and then I give it the keyword input or output, and in this case I'm going to do output, and I do it in all caps, and notice that it turns blue, so the development environment noticed that it was a keyword. And I have just now set up pin 13 as an output. So great. And what I can do now is let's do the exact same thing on pin 12, and you can do it by copy and paste, and now I have set up pin 12 as an output, and they're ready to go. So now I'm sitting there going, well, how do I drive it to a high or low? And I use our other function that we just learned, which is going to be called digital write. And the way that this digital write works is the first argument is going to be the pin number. So let's go ahead and write to pin 13, and then I'm going to set it to high. And what that's going to do is it's going to turn on LED on pin 13. And okay, life is good. So now let's go ahead and copy and paste that and do it for pin 12, and then we'll do that. But when I run my program, they're just going to turn on and off, or they're just going to turn on. So what I'd like to do is have it kind of blink back and forth. So let's go ahead and go back before that and do a print where I'm going to say turning LEDs on, and then I can kind of track what's going on. Because I just turned them on, let's go ahead and now wait a second and then turn them off. So I can wait a second by doing a delay of 1,000 milliseconds using our delay function, and I've basically turned them on and waited. And now with a copy and paste, I can simply say, all right, now let's turn them off. And all I do there is I do a digital write to pin 13, and I say low, and the keyword turns blue, so the Arduino development environment recognizes it, and I can update my comment right here, and this should work. So let's go ahead and fire this up. I got my board all plugged in here, and it's going to work. And let's see, I'll go ahead and I'll turn on the camera here so that you can see this. And I also want to get my digital monitor up, or my serial monitor up. All right, here we go. Activity 2, LEDs blinking, and on and off. And here we are. So check this out. I have my LEDs on here, and they're both turning on, both turning off at a rate of 1 second. I did it. Pretty simple, pretty straightforward. And now, why don't you go ahead and do it? So go ahead and pause the video and code up an Arduino sketch to configure pins 12 and 13 as outputs using the pin mode, and then use the digital write to turn them on and off at a rate of 1 second, and then go ahead and print something to the serial monitor like I did so that you can kind of track what's going on. So go ahead and do that, and you can pause the video for it. Okay, so now at this point, what we need to do is we want to look at driving another type of output, another type of common thing, which is going to be a servo motor. And let's talk about the servo motor first, and then we'll talk about the code for it, and then you'll actually put the servo motor connected up to your Arduino. So the first thing is these servo motors are from Parallax, and servo motors are they're DC motors that have some built-in sensors in them that kind of track what's going on. It's all abstracted from the user in these servo motors, so we just send it a control signal and power and ground, and we can tell it to move counterclockwise or clockwise. These are continuous servo motors, meaning that they can spin all the way around in a circle. So they can basically go in a circle forever, and they're really good for driving wheels and stuff like that. Some servo motors are not continuous, so they'll only move, like, for example, 0 to 90 degrees, and you essentially tell it, you know, go to 30 degrees, and it'll go there and stop, and then go to 40 degrees, and it'll go there and stop. The BOE Shield actually has 4 connectors right here that are used to drive servos, and they're on pins 10, 11, 12, and 13. Okay, and so they're going to be up here. And in addition, what's really great about this is that the Arduino has a servo library that provides these built-in functions to control the motors. Now we're going to start off, we'll connect them to 12 and 13, and let's leave our LEDs connected. And the reason we're going to do that is because we're going to be sending this fast control signal to the servos, and it won't turn the LED all the way on or all the way off. It'll kind of be dim, but it's an indicator that we're actually sending something to the servos. So we're actually going to kind of have 2 things connected to pin 12 and 13. Okay, one note on pin 13 is that when it boots up, when the Arduino boots up, it'll actually pulse pin 13, and that's fine for what we're doing right now, but once you actually try to build a system that has to work, you know, from startup, we'll probably want to move our servo over to like pin 11 or pin 10, something that doesn't pulse on startup. But if you see these things pulsing on startup, that's what's going on. Okay. The Arduino servo library is included by using a pound include, and then the syntax is servo.h with a capital S, and you have to put this at the beginning of your program. Then what you do is you use a keyword servo, and then you give an instance name for each motor that you have. So if you have 2 motors, you need to do 2 servo instances. If you have 4 motors, you have to do 4 of them. And this servo left is a user-defined name, so I just made that up. Servo right is another thing I made up. You can make up your own names. But the way that you can think about it is that that instance of the motor is going to be where you send these commands to. So you have to declare these instances after the include statement, but before you actually get into your begin loop. So those things have to be right there. Okay. Then there's 2 other commands that are interesting. One is attach and one is detach. And as soon as you attach the servo, what's going to happen is you tell it which pin the servo is on, and at that moment then you can send information to that pin, and you'll send it in a particular format, which we'll see in a second. The syntax for it is servo left, so that would be our instance name, and then dot attach, and then you give it the pin number. Detach is after you've been driving the servo for a while, you can actually detach it. And the reason you would ever detach is because once you start sending a signal to the servo, it'll stay going to the servo until you tell it not to. So you'll see that we send signals to tell the servo go counterclockwise, go clockwise, or stay still. And sometimes when you're having it stay still, you don't want that signal being sent. You're just wasting energy by sending that signal to tell the motor to do nothing. So if you keep it attached, you have to send that signal continuously. So sometimes you'll do a detach and actually stop sending that signal, and then the motor will just not spin just because you're not doing anything to it. For most of what we're going to do, we're just going to keep it attached and tell it to just sit there actively. Okay, how do you control the servo? The way that you do it is you send what's called a pulse width modulated signal. Now, a pulse width modulated signal is a repetitive series of pulses, and these pulses have a width to them, and the width of the pulse itself is the control signal. So for example, if it's a certain width, it might tell the servos don't move. If it's wider, it might cause it to turn a certain way. If it's narrower, it might cause it to turn a certain way. So that's how we're going to actually do this control. Okay, in this situation, the servo library actually handles sending these pulses for us once we do this command called write microseconds. And it'll send these pulses every 20 milliseconds, which is 20,000 microseconds. But what's kind of neat about it is that all you need to do, the argument for this, is you just tell it to send a particular pulse width in microseconds. So I specify right here as the argument the number of microseconds that I want the pulse to be high. Now, how do I use this? Well, it turns out that these servos, if you send them a 1500 microsecond high time, that is the stay still state. So that's where you tell them don't move. And the syntax for it is servo left, that is the instance user defined, I made that up, and then the command is dot write microseconds with a capital M, and you simply give it the high time. If you want to send it to the other servo, you give it the other instance name, which in this case is servo write, and then you do write microseconds, and then 1500. Now, when you first pull these out of the box, what's going to happen is that they need to be calibrated. Okay, so calibrated means you're sending it a signal that needs to be, it means to sit still, but out of the box they might spin a little bit, or they might vibrate a little bit. And so you have to actually adjust them to get them into a state where they won't spin. And we do it by, there's a little Phillips head screwdriver that comes with a kit, and you stick it in the side of the motor and you can adjust it, and we'll do that here in the next activity. Okay, to get it to go clockwise, you send it a a smaller pulse, and the smallest you can send it is 1300 microseconds, and that represents spinning clockwise as fast as possible. And all you do is you just do the write microseconds 1300, write microseconds 1300, and of course you can send anything in between 1300 and 1500 and it'll just spin slower, so you can kind of ramp it up all the way to full speed or ramp it down, but 1300 is as fast as it'll go. And then counterclockwise, you send a fatter pulse, and the maximum is 1700. So you just send that to it, and this would cause it to turn counterclockwise as fast as it possibly can go. Okay, and again, you can go in between. Okay, so now what we're going to do right now is let's go ahead and fire up a new sketch, and let's write the stay still program. Okay, so I'm going to go ahead and do a new sketch, and we're not going to test this yet because we don't have the servos connected, so that'll be the next activity. But what we can do is just look at how we use the syntax of the servo library and figure out how to actually use it. Okay, so what I'm going to do is I'm going to go ahead, and the first thing I'm going to do in my sketch is I'm going to save it. So I'm going to go File, Save. And let's go ahead and put this on our desktop where we've been working, and under Arduino, and we'll call it Chapter 2, Activity 3, and then we'll call it Servo Stay Still. Okay? Alright. First thing we need to do is we need to go in and we need to include the servo library. So I'm going to do a pound include. And then I'll go ahead and do servo with a capital S .h. I've now included my servo. Okay, that's the servo library is now in there, and it gives me access to all the functions, the built-in functions. Okay, now I'm going to do a keyword servo, and notice how it turns orange. That's a keyword. And what we're going to do is I'm going to create these names of my motors. So I'm going to call the left one servo left, and I'm going to call, then I'll do another servo function again and say servo right. And I have declared, so these are declaring instances of the motors. And from here on out, I can use these names when I drive, when I actually send commands to it. Okay, now let's come in down here, and of course I'm always going to be doing stuff with the serial monitors, so I always want to set up my serial monitor. So I'm going to do a serial.begin and 9600, and then I'll do a serial.print, and I'll call this activity 3 and we'll say Servo Stay Still. Okay, and that tells me that I'm running the right program, so I know that. And then I'm ready to actually start putting some code in here. So the first thing I need to do is do the attach function. So the way that I do that is I go servo left, that's my name of the motor that I'm doing, that I'm going to do something with, and I do keyword attach, and then I give it the pin number. So this is going to be on pin 13. So it's basically, you're saying, hey, servo left is now active and it's on pin 13, and that's where I'm going to send information. I'm going to do the exact same thing with servo, the servo right, which is on pin 12. Okay, so I just do a servo right. Okay, and this is basically attach servos and tell pin numbers they are on. Okay, life is good. Okay, so now I'm sitting here and my servos are attached and they're ready to start going, and I would like to, I'm going to come down here. Actually, I don't even need to do that. Let's do it right here. I'm going to go ahead and send out the command to tell the servos to stay still. The way that I do that is like this. I go servo left, I put my instance name, and then I go at period, and I go right microseconds. And then I give it how many microseconds I want to send, and it's 1500. That's the amount of time that the pulse needs to be high in order to stay still. Okay? And let's go ahead and you do a lot of copy and paste when you're doing this stuff, so Control Z and Control V. So we'll do a servo right, and I'm going to send that thing. So now I'm sitting here, and I want to do one more message to myself to just know that I'm where I'm at in my code. So I'm going to do serial print. I'm going to say telling servos to stop. Okay? And that is essentially the entire program. Okay, so we don't have anything else. We're just going to send that signal. What's neat about it is that these things right here will send, and those signals will continue to send even as you move to other code statements. So for example, if I put another print statement and said just sent signal, it won't like call this function and sit indefinitely in here. It just turns on the signal, the pulse width modulated signal, and leaves it running forever, and then it goes on to the next statement. This one turns on the servo right pulse width modulated signal and leaves it forever, and then it moves to this. And that's kind of neat because you don't have to sit and continually call this to generate the pulses. You just call it once and it's off and running. Okay, so let's verify this and make sure that it's okay and doesn't have any syntax errors. So we go ahead and verify it. And no problem. Okay, so at this point, why don't you do that? So go ahead and write the program that I just did, and we're not going to use it right now because we got to attach our servos and battery pack, but we want this program because the first thing we're going to do is actually download it and calibrate our motors. So go ahead and pause the video and write that program. Okay. At this point, we have a program to tell our motors to stay still, but it's time to actually connect them. So what you're going to do here is you're going to take your servos and you're going to plug them into the connectors for pin 13 and pin 12, and then you're going to take your battery pack and you're going to put in your AA batteries and plug it into this jack down here. Be careful to make sure that you align the black and the red per the marking on the BOE Shield. You can plug these in backwards and you'll blow up the servos, or you'll damage the servos or damage your board if you plug them in backwards. So just make sure to follow that. When you first take these out of the box, they're a little tight, so you kind of got to push on them a little bit to get them to pop all the way down. But go ahead and plug those in, and the way that this works is that each servo gets a +5 on the red, a ground on the black, and then it's got a control line on the white. And the way that the BOE Shield is wired, pin 13 is going to be where you send the control down the white for this servo, and then pin 12 is going to be connected to the white wire right there. Okay, so go ahead and do that, and you just leave them out on your bench. You know, you don't have to connect anything together. What we want to do is just get them out here, and the first thing we want to do is mess around with actually with calibrating it and see what happens. Okay, all right, so go ahead and pause it and connect those up. Okay, it's time at this point to calibrate your servos. All right, when you send that stay still signal to it, they should not be moving. So what we want to do is we want to bring up our stay still program, okay, which is going to be right here. And let's go ahead, and you've got everything plugged in. Go ahead and plug in the battery pack. Keep the switch on 0, the power switch on 0 when you first download. And let's go ahead and download that. And you kind of know it's running by bringing up the serial monitors. Okay, so now it sent the signal, and then it said just sent signal, so that means that it got through it. What I want you to do now is go ahead and come over to your board, and when you turn on, first of all, notice that the LEDs are dim. The reason that they're dim is because you're sending this really fast signal to the servos, and it's not enough to turn it on all the way or turn it off all the way. It's kind of like right in the middle, so you'll see that they're dim. And this is good because it tells us that the signal's being sent. If you ever see that LED not dim, then that means that your PWM signal is not being sent. When I turn this switch over to position 2, it's going to allow the batteries to generate or to power the servos. We want to power the servos with the battery because, let me move this so you can see a little bit better. You want to have the batteries power the servo because the servos take a lot more current than the USB cable can provide. Okay, so here I go, and I'm ready to turn this on. And one of them is spinning and one of them is not. And it's like, okay, it shouldn't be spinning. So what I got to do is I got to calibrate it. So I'm going to take this Phillips head screwdriver, and I'm actually going to stick it into this little screw, or this hole in here, and I'm going to adjust it ever so slightly to get it to the stop position. Okay, and you kind of play around with where it needs to be, and it's really subtle. You just want to have it in the position where it's not moving and it's not vibrating. So it's not moving right there, but it's clicking, it's vibrating. So I just got a tiny bit more, and I'm good to go. Be very gentle with it, because you can actually, if you're too rough with the screwdriver, you can actually break that little, they call it a potentiometer. It's a resistor that you can change the value of when you actually turn the screwdriver. Okay, so at this point, I didn't need to calibrate that one. It was fine. I can go in there and kind of make sure that it's alive. But yeah, I can mess around with it and get it back to staying still. There you go. Okay, so at this point, things are great because I have my 2 servos and I have my battery pack, and I'm sending signals to them to stay still. So at this point, what you should do is calibrate your servos. Send that stay still program that you wrote down to the Arduino. Go ahead and power them by moving to position 2 on the power switch on the BOE board, and then go ahead and use the Phillips head screwdriver to calibrate so that they're not moving. So go ahead and pause the video and do that. Alright, it is finally time to write some code to make the servos spin. So what we got to do is, let's go ahead and bring up a new sketch. So I'm going to do a file, new, and I'm going to have a new sketch. And I'm going to call this is going to be, let's call it Chapter 2 Activity 6, and we'll call it Test Servos. So the first thing I want to do is I want to not close it. I want to save it. So File, New, and I'm going to go ahead and save it in our desktop Arduino folder. So File, Save, and I'll go ahead and go Desktop, and then I'll do Arduino, and then I'm going to do Chapter 2 Activity, what are we on here, 6. Okay, so we're on Activity 6, and this is going to be called Test Servos. Okay, now I'm going to go ahead, I had my Stay Still program from before. I'm going to go ahead and copy everything in it because I already wrote a lot of the code to do this. So I'm going to go ahead and do that, and then I'll close my prior one. Now at this point I should be able to save it, and I should be able to download it. So I'll go ahead and download it and make sure that it's alive. So then I'm going to pull up my serial monitor, and at this point I'm ready to, I know it works, I know it downloaded, and life is good. Okay, so here's what we're going to do. Let's think about how we turn this one of the servos. I want to start, I'm going to leave this stay still code right there, and I am going to, let's make the left servo spin clockwise. So how do we do that? Well, you know what? I already have the code right here to send it a signal. So I'm going to go ahead and I'm going to bring these down right here, and I'm going to paste them in the loop. Okay? And what I'm going to do is, the first thing I'm going to do is I'm going to print myself a message that says left servo spinning clockwise. And that is going to say, okay, when I see that message, I know what's coming next. Now, how do I do it? Well, I'm going to leave the right servo at 1500, and you don't even really need to have that command in there because it's still up here. But I'm going to put in a command right here to turn this to clockwise. So what's the value that we need to do? Well, I'll go back to my little drawing here. To turn it clockwise, you need to be 1300. Okay, so 1300 microseconds. All I do is say 1300 microseconds, and that should do it. But now you think about this, it's going to be in this loop. What I'd really like to do to know that I'm controlling it well is let's tell it to spin as fast as it can clockwise for a second, and then let's stop it. So how do you do that? Well, you just simply put a delay in here. Let's delay it for 1000 milliseconds, which is a second. And at that point, let's now stop it. And how do you stop the servos? Well, the way that you stop it is you just send them both 1500 again. And I want to give myself a nice comment here, so I'm going to put stop. All right, and I want the delay in here also, because what's going to happen is it's going to sit in this loop. It'll go turn them on for a second, stop for a second, turn them on for a second, stop for a second. Let's go ahead and save and download this, and let's make sure that we can actually spin this, because we're to the point now where some really neat things are happening. Okay, so when it boots up, you see this thing kind of pin 13 flash, and that's fine. So you'll see the servo motor blip, but now we're in our program, and the way I know that we're in my program is the serial monitor is printing these things out. But look at our motor. It's spinning clockwise, and it is going for a second and stopping for a second. We did it. All right. Check out what we can start doing when we just do copy and paste. I would like now to tell it to spin counterclockwise for a second and then stop. I am simply going to copy and paste this and paste it right below. Immediately when you do that, you start looking at your code and going, wow, this is really getting hard to read. So I'm going to go ahead, and first thing I'm going to do is I'm just going to put some line comments right here so that I can at least break up like my individual statements. And now I'm going to come down here, and I'll go ahead, and I'm still sending to my left servo, but I'm going to do it counterclockwise. And how do I do it? Well, instead of sending it 1300, I'm going to send it 1700. And then this right here is still okay. This is the stop command. So let's see if that works. So I'm going to compile this and upload it. And here we go. And here we go. Look at it. It's going clockwise, then counterclockwise. Clockwise, counterclockwise. Clockwise, counterclockwise, clockwise. It's working. Now check this out. What if I wanted to test the left motors all the way through like I just did? Let's do the right motors. I'm going to take this entire thing and turn them on and off for a second at a shot, and turn them clockwise and then counterclockwise. So I copied and pasted that. I'm going to go ahead and make this my comment, right servo spinning clockwise. How do I do it? Well, all I do is I change my left servo to 1500 and my right servo to 13. That's going to send the command to the right servo, and then I do my stop. It's the same. And then I do come down here and let's change our right servo. And what I want to do is, instead of sending 1700 to it, I'm going to send it 15, which is the stop, and I'll send 1700 to the right. And look at this. I'm going to go ahead and do this, and I should be able to drive both motors now. Okay, so here we go. So it's downloading. Watch the little blink on there when it's downloaded. It blinked it. Here we go. So left, right, left, right, and my message tells me exactly what's going on. So we have done it. We are now writing an Arduino program to control servo motors. This is fantastic. So here's what I want you to do. Go ahead and you do it. So this is the end of the video. Go ahead and create a new sketch and do exactly what I did. Turn the left servo clockwise for a second, stop for a second. Turn it counterclockwise for a second, stop it. Then do the right one, clockwise for a second, stop for a second, counterclockwise for a second, stop for a second. Then you add code to spin both servos clockwise for a second and then stop for a second, and then spin both servos counterclockwise for a second. So you get to add that. And at every step of the way, go ahead and print the status to the serial monitors that you're going. Okay, good luck.